Hello, everyone. If you've tuned in for Woods Hole Oceanographic Institution's Ocean Encounters presentation, Rising Seas, Resilient Coasts, you're in the right place. Joining us tonight are Barnstable County and WHOI Sea Grant Floodplain Manager Shannon Hulst, WHOI Sea Level Scientist Chris Piecuch, and City of Boston Resilience Manager Hannah Wagner. Stay with us. Hi, everybody. In just a few minutes, we'll get started with Woods Hole Oceanographic Institution's Ocean Encounters presentation, Rising Seas, Resilient Coasts, Understanding, Predicting, and Adapting to Sea Level Rise. We've still got a lot of people joining us, so thank you for your patience. Hello, you've joined Rising Seas, Resilient Coasts, a Woods Hole Oceanographic Institution Ocean Encounters presentation. We have a lot of people joining us tonight, so sit tight. We'll get started very shortly. And now, please take a moment to read WHOI's land acknowledgement.
The ocean covers 70% of the globe. It gives us oxygen and food and millions of jobs. It brings joy and shapes our climate and weather. The ocean is life, and it belongs to everyone. Woods Hole Oceanographic Institution is the world's independent leader in ocean discovery, exploration, and education, working to understand and sustain one of humanity's most precious common resources. Join us today for our ocean, our planet, and our future.
Welcome to Ocean Encounters, a virtual series from Woods Hole Oceanographic Institution, or WHOI, as we like to call it for short. Tonight's event is Rising Seas, Resilient Coasts, Understanding, Predicting, and Adapting to Sea Level Rise. My name is Veronique LaCapra, and I'm the host of Ocean Encounters. As you might be able to tell from my voice, I'm a little bit under the weather tonight, so please bear with me. We are now in our 6th season, and I'm happy to share that our series has once again been named an endorsed activity of the UN Decade of Ocean Science for Sustainable Development. I'd also like to thank our sponsors. WHOI's Ocean Encounters events are made possible in part by the Avatar Alliance Foundation and Dalio Philanthropies, so thank you to them. Thank you also to any WHOI members who are joining us tonight. You are the heroes at the heart of our efforts. Before I introduce our speakers, I want to let our Zoom audience know that they can participate in tonight's live conversation. If you have a question for one of our panelists, please use the Q&A button on your Zoom screen and type your question in the window that appears. You might be more familiar with the chat function in Zoom, but please ask your questions using the Q&A button instead. We often get hundreds of questions, so I apologize if we don't get to yours while we're live. You can ask questions anytime, starting now. I also want to let you know that we are recording this event. That recording will be made available on the whoi.edu website. We had 2,660 people pre-register to join us tonight, so you are in very good company. We also have viewers joining us right now on Facebook and YouTube, and tonight for the first time also on X and on LinkedIn. Thank you and welcome to everyone. Let's get started. Sea levels are rising, but they're rising at different rates in different places, with differing impacts for coastal communities and ecosystems. To predict and adapt to future sea levels, we need to understand where and why they're rising now, and have risen in the past. Tonight, we'll talk about what's driving rising sea levels, what they mean for coastal habitats and people, and how adaptation strategies can help protect lives and livelihoods and make our coastlines and infrastructure more resilient to climate change. Here to tell us more are Barnstable County and WHOI Sea Grant Floodplain Manager Shannon Hulst, WHOI Sea Level Scientist Chris Piecuch, and City of Boston Resilience Manager Hannah Wagner. Welcome, everybody. All right. Let's start by having you each introduce yourself. Just tell us your area of expertise and very briefly what you work on. We'll get into more detail on all of that throughout the evening. Let's start with Chris, and then Shannon, and then Hannah.
Great. Thanks, Veronique. So my area of expertise is the science of sea level rise. When I was in college, I studied physics and math. And so now here at Woods Hole, I use physics and math to investigate, to tell the story of how sea levels have risen and are rising, but also why sea levels have risen and are rising. And I do that using observational data, computer models, and also natural indicators.
All right, and Shannon?
My area of expertise is something called floodplain management. So it's the wise use of our nation's floodplains, looking at the ways that we develop in our floodplains. My background is policy and interdisciplinary science, law, and policy. So I focus mostly on regulations and also look at flood insurance specifically.
And Hannah.
Great. Thanks so much for having me tonight. I work for the City of Boston Environment Department, and I'm focused on protecting Boston's 47 miles of shoreline to the effects of climate change, including sea level rise and coastal storms, in a way that keeps the city thriving and keeps residents and the community safe. Thanks for having me.
I want to hear more about all of that, but I'm going to start with Chris and a little bit of the science of what we know and don't know about sea level rise. First off, how do we even measure sea levels? What tools do we have to measure them? And what are we actually comparing them to know how high they are and how they're changing?
Yeah, right. So there are actually a few ways that we can measure and observe sea levels and how they're changing. The first are tide gauges. So these measure sea level relative to a fixed point on land. So in the photos you'll see right now, I'm showing some tide gauge stations around the US. Here's the one up in Boston that you may be familiar with. So tide gauges have been installed in some ports and harbors around the global coast for decades, if not centuries. Earlier in time, these devices consisted of a hollow tube, what we call a stilling well, that would extend above and below the water surface. And inside that stilling well sat a flotation device. And the flotation was attached to a counterweight and pulley system that allowed the sea level to be recorded as the tides rose and fell. More recently, we use more modern technology, things like acoustics and radar. So with these tide gauges, we have a view onto the past, again, going back decades or centuries, but only in some places, only in these ports and harbors. It wasn't until the early 1990s when we had satellite measurements that gave us a truly global picture of sea level rise. So what I'm showing now are what are known as satellite radar altimeters. And these measure sea level relative to Earth's center of mass, which is the point around which these satellites orbit. So the way that these work is they send a radar pulse down to the sea surface. That pulse reflects off the sea surface and comes back to the satellite. And by knowing how fast that pulse travels and how long it took the pulse to go there and back again, we're able to deduce how high the seas are. So
Wait,
when
now
we combine
you said
those,
they measure it against, did you say the center of mass of the Earth?
yeah, so the Earth's center of mass is that point in which that the satellites are orbiting around. So these are referenced to Earth's what we call the geocenter.
Okay.
Yeah. So when you take these measurements from the satellite altimeters and the tide gauges, and you combine it with other global Earth measurements like these gravity satellites that I'm showing now, we're able to say a few things. Like one, we know that global sea level is rising, and two, we know that it's rising because both we're losing ice on land, and that's increasing the amount of water in the ocean, but also because ocean waters are warming and expanding thermally.
Okay, we'll dig into some more of that in a bit. But so those are the tools. But now, what changes are we actually seeing? And I want to let our audience know that tonight we'll be mainly using examples from coastal Massachusetts, specifically Cape Cod, which is where WHOI is, and north of us in the city of Boston. But we will try to touch on other areas as well. Shannon, let's go to you first. How quickly are sea levels rising here in southeastern Massachusetts?
Yeah, so we are definitely seeing sea level rise happen. A really great way to illustrate what we're seeing with sea level rise is through our storm of record. So a storm of record is basically the largest amount of flooding that we've had in recorded history, which is not that long. We haven't had records for that long, but in our recorded history, the blizzard of 1978 had been our storm of record, or the storm with the largest amount of flooding. But in 2018, we had a series of nor'easters that were significant, and one of them broke that 1978 storm of record. And this is interesting and illustrates sea level rise because the storm surge that came in 2018, so basically the increased amount of water that that storm brought with it, was actually smaller than what we saw in 1978. So how did it end up breaking the record? Because of sea level rise. So we saw about 6 inches of sea level rise between 1978 and 2018. And so that allowed, those 6 inches of sea level rise allowed a smaller storm in 2018 to break the record of 1978 and give us more flooding in 2018.
Got it. So the fact that globally sea levels had risen made that storm more impactful. I actually remember the blizzard of 78. I'm old enough to remember it. I got a lot of days off from school, so I was very excited about that. Hannah, what are you seeing in the Boston area?
Yeah, thanks for this question. So similar to what Shannon just said, we've seen sea level rise over time, and this is combined in a very interesting way with the history of Boston's development and evolution. So here you can see a map of Boston's historic shoreline, so that white landmass in 1630 compared to a present day shoreline. You know, some small changes here or there since 2016, but that's what that yellow line is showing. And so you can see in the, really in the 3 centuries following Boston's founding in 1630, the footprint of the city increased almost by 50%. A lot of that land along the coastline and riverbanks, filling in sort of marsh areas and wetland areas to just above high tide level at that time. And so really what this means now is that a lot of the areas of the current landform are just above high tide and are, as we see sea levels are rising, are experiencing flooding. So there are some very low-lying areas like you see here with the Chart House, which is a sort of a Boston landmark on Long Wharf in downtown Boston. Some of you might be familiar with the New England Aquarium. It's right in that area of downtown Boston. So these really low-lying areas are subject to flooding from sea level rise, from coastal storm events and wave action. And sometimes you can go out during a high tide, even on a sunny day, and see flooding on this Long Wharf area and really low-lying areas around the city.
I just want to go back to that map that we saw first for a second. It's so amazing to me. I just love this map. But so all these areas were underwater, but they were filled in, built up so that we could have more area to the city of Boston.
Exactly. Right? So we're zooming in now on what is sort of the Logan Airport area. People might be familiar with that in East Boston. So next time you're maybe landing in Logan Airport, think about how that land was all created over the course of history. And yeah, so a lot of the city has just created wharves and marsh areas, and that overlays pretty well with areas that might experience flooding in the future.
Yeah, we'll see that in a bit. So Chris, in the introduction, I alluded to the fact that sea levels don't rise at the same rate everywhere. How does what's happening in New England compare to other parts of the US and of the world?
Yeah, great question. So, right, it sounds kind of odd, but it's actually true. Sea level rises at different rates in different places, actually for different reasons. And one of those reasons is ocean currents. Before I dive into that, though, to answer your question, here in New England, we actually experience a rate of sea level rise that's faster than the global average. And to try to get this point and your earlier point across, I'm showing this map here. So the global map of how much sea levels have risen globally over the past 3 decades. So all the color shading that you're seeing over the ocean, these are the data from those satellite altimeters I mentioned. And then all the colored dots along the coast are from those tidal gauges I mentioned earlier. Just to orient you, if you see a warm color, that indicates sea level rise over the past 3 decades, whereas cool colors indicate sea level fall. And these are all showing rise in units of inches over the past 3 decades. Few things to notice. One, you see a lot more warm colors than cold colors. This is that global average sea level rise I mentioned a few minutes ago. It's due to the warming and expansion of the oceans, but also the added mass of water to the ocean from the loss of ice on land. Second, you don't see a wash of just one color. You see these rich, intricate, detailed patterns over the ocean, which is illustrating this fact that sea level rise is happening at different rates in different places. And like I said before, this has partly to do with ocean currents. So I'll talk about this map all day, but I'll show restraint and just point out a few things. So first, let's look at like the tropical Pacific Ocean. Over the past 3 decades, there's been a lot more sea level rise in the west than to the east. You can see this by the kind of lighter, paler colors off the coast of the Americas and those deeper reds that you're seeing around the Philippines and Papua New Guinea. This has a lot to do with a gradual weakening of the low latitude trade winds, which blow from east to west over the past couple of decades. So that's one important feature. If you move away from the equator and start going towards the poles, you can kind of pick your ocean basin. You'll start to see these really small, almost circular features that show these kind of alternating red to blue to red to blue colors. These are the signatures of what we call ocean eddies. They're kind of like storms in the sea, and they result from the inherent instability of ocean currents, much like our own weather that we experience on land. So those are just a couple examples of some of the things that go on in the ocean that result in these really rich patterns of sea level rise, seas going up more in some places than others.
Say what you said about the trade winds again. So the trade winds are pushing ocean water in which direction? But you said they're weakening.
Yeah, so the trade winds, they're close to the equator and they blow from east to west. And they basically pile up more water to the west than the east. Okay, so if you have a change in those wind patterns, they can change that sort of seesaw of sea level across the tropical Pacific, and that's what we've seen over the past 3 decades, related to things like El Nino and other variations in the climate system.
Okay, so I get that, but what are some other reasons that sea levels are rising at different rates in different places? You talked about ice melting, which seems like, I mean, isn't the ocean just like one big bathtub? So you'd think it would just rise everywhere kind of the same besides those winds and currents. So what's going on?
Yeah, so in addition to what's happening with the ocean currents, there are all kinds of other things that are going on in the Earth system that also cause patterns of sea level change. So you talked about ice. This is certainly one of the things we think about with climate change. And sure, when you lose ice on land, say when that ice melts, that water runs into the sea and it raises global sea level on an average. But that's not the only thing. It turns out, actually, if you could go back one slide really quick to the beginning, there we go, we'll start there. Yeah, so we're raising sea levels on a global average, but that's not the only thing. When you melt or lose an ice sheet, you actually change the shape of Earth's surface and its gravity field. So I'm going to use this cartoon to kind of illustrate these. And Craig, as I'm talking, you can kind of cycle through these kind of slowly. So the really most important thing here is to remember that ice sheets are incredibly massive. They're so massive that, as I'm showing in this figure with the white ice sitting above the gray Earth, that ice actually weighs down and sinks the land beneath it. Not only that, if this growing up of an ice sheet happens over long periods, it can actually penetrate deeper in the Earth, causing material in the mantle to move outwards away from the ice sheet. An imperfect analogy is like when you go into bed at night and your mattress sort of sinks beneath you. And if we sort of plumb this metaphor a little bit more, what happens when you wake up in the morning? Well, your mattress goes back to its former shape. And so this is kind of the analogy for when we melt an ice sheet, as I'm showing here. You melt that ice sheet, you lessen the weight of that ice sheet, the ground is able to actually rebound back up again. It's even have this deformation, this reshaping of Earth's surface. But that's not the only thing. As I said, ice sheets, they're massive. They're actually associated with an incredible gravitational attraction. such that the ice sheets actually pull seawater close to them. So around an ice sheet, you can see in this image here, sea level is actually a little bit higher right near an ice sheet. Okay, but again, once we lose mass from that ice sheet, it melts away. Yes, you're adding water to the ocean. It rises on a global average, but believe it or not, sea level actually falls locally around the ice sheet because of that lost gravitational attraction and that weakened ability for the ice sheet to pull water close to it. So that's another process that can cause sea level to rise unevenly in some places, dropping near the ice sheet, but rising much more as you go farther away from the ice sheet.
That's so fascinating. I love that. And I love the getting out of bed in the morning analogy. That works really well.
It's a good one.
So with all of this, how do current day rates of sea level rise compare to past rates? In other words, is what's happening now that unusual? And how do we know?
Yeah, it's a really important question. So how do we know? Like I said before, we only have these instrumental measurements, things like the satellite altimeters and the tide gauges, only for a couple decades or centuries. But if we want to, as you say, put the current observations in like a longer term geological context, we need to go back deeper in time. And of course, we don't have measurements then. So this is where things like natural archives come into play. Okay, so just for example, salt marshes are coastal ecosystems that, oh, sorry, I should introduce this video. So what you're seeing here, there's some video footage and some images you'll see from some field work we did just a little while ago to Prince Edward Island in Canada. So you see us here trudging through these very wet marshes, digging up buried sediment that was laid down a long time ago. Why in the world are we doing that and laughing about it apparently in this figure? Because it's telling us about past sea levels. So salt marshes are these really unique environments that, given the right conditions, they actually keep pace with sea level rise. They accumulate sediment and they grow vertically. What this means is that over time, older sediment is continually being overlaid and buried by newer sediments. And buried with that sediment are microorganisms and organic matter with it. So by digging up the sediment, like we're doing here, we have a window into the past. So more specifically, we can use radiometric dating to take any organic matter that we find in these pores and date it to tell us how long ago that sediment was laid down. We can also scrutinize under a microscope the tiny microfossils that we find because those microfossils are from species that have certain preferences for different tidal levels. So they can tell us how high the seas were back in time. So we have a date and we have a level, so we know what past sea levels were. So the cores that we're getting here tell us about sea level rise in Prince Edward Island going back a few thousand years. So with these cores and cores collected elsewhere in the globe, getting back to your original question, we're able to pretty confidently say that the sea level rise that we've seen globally over the past century, again from tide gauges and altimeters, is the fastest that we've seen in at least the past 3,000 years. So it's pretty unique.
Okay, so now I want to bring in our audience. Let's go ahead and take our first question. My colleague Ken Costell is behind the scenes fielding those. Ken, what do you have for us?
Well, the audience was very fast out of the gate. I'm going to give the first question to William, who was the first question in the queue. And he's asking whether post-glacial crustal rebound has ceased or not.
Has what?
Has it stopped?
Oh, has it stopped?
Yeah, I can handle that real quick.
That's a good question.
Yeah, great question, William. So no, it hasn't. So the phenomenon that William is talking about, this so-called post-glacial rebound, or what we also call in the field glacial isostatic adjustment, this relates to those ice cartoons that I was showing you before. So 25,000 years ago, we were at the height of the last ice age, but we're not in an ice age now. In fact, all of the ice from that last ice age had melted away by about 7,000 or 8,000 years ago. But that, again, using that analogy of the bed reforming its former shape as we get up in the morning, in our experience, that happens in just a couple seconds. But the Earth responds over a much, much longer time scale. So even though we lost most of that ice thousands of years ago, that process of the Earth regaining its former shape has been ongoing and is still ongoing and will continue to go on for centuries. And in fact, this post-glacial rebound process that William's asking about is really responsible for the fact that you get much faster sea level rise around the mid-Atlantic, places like the Chesapeake Bay or around Cape Hatteras. These, at least along the U.S. eastern seaboard, these are the places where you get the fastest sea level rise, and that relates precisely to this ongoing post-glacial rebound process.
Okay, let's take one more question, Ken. Go ahead. Sorry.
Sure. So as a child of Lake Michigan, I have to ask this one. Carol asks, are the Great Lakes affected by sea level rise?
That's a great question. So no, they're not. So the Great Lakes, of course, you have winds and all, some of the processes that I talked about, like the blowing of winds that will shift water from place to place. Of course, that goes on in the Great Lakes. But because you don't have these huge connections to the global ocean, you don't have sea level rise for the same reasons. You may have the lake levels change due to management and things like this in certain places, but a lot of the processes that we're talking about are not going on.
All right. So we've been talking about what's happening to sea levels now and how that compares to the past. But how good are we at predicting what sea levels are going to do in the future, both on average and at any given location? Chris, what tools or approaches do we have to make those kinds of predictions?
Yeah, that's a great question. Well, I've talked a lot about observations. Of course, we don't have observations of the future. But to inform our sense of what's going to happen, we can use that knowledge we've gained of the past. In other words, we can take that process-based observational understanding that we've gained from salt marsh sediments, the altimeters, et cetera, and we can code that knowledge into computer models, okay, which can provide us with scenarios, or if you will, storylines of how sea level may change in the future, depending on a bunch of factors, things like future greenhouse gas emissions. So here I'm showing an example for Boston. So here, just to orient everyone here, I have time running along the bottom on the horizontal axis from 1980 going through the next century. And then I have sea level rise on the vertical axis to the left. And this is all shown relative to conditions in the year 2000. So the gray and the black symbols that you see, these represent the observed past change, in this case from a tide gauge up in Boston. And then all the colored curves that you see to the right are indicating different scenarios, possible future sea level rise from low to high. So I'll just point out a few features here. One is that none of these future storylines shows sea level stopping its rise or falling. In all scenarios, we're going to see sea level rise in Boston and elsewhere through the century and beyond. The second thing, if we still keep looking at these colored lines, for the next, say, 25 years or so, from now to mid-century, all those lines are really, really close together. What this is telling us is that we're pretty confident about the projections over the next couple of decades. There's very little uncertainty. And part of the reason for this is that these rates are already kind of set in stone in a lot of ways based on past action, things like previous emissions. It's not until you go past the middle of the century that you start to see this really wide divergence in those curves. For example, that low curve is less than 2 feet of rise at Boston between 2000 and 2100, whereas that yellow curve, the yellow curve, the high curve is showing more than 5 feet of rise by the end of century. And this increasing range is driven by uncertainties and things like future greenhouse gas emissions. So you might ask, well, what's causing this future rise? Well, I'm showing here this bar plot of the causes, sort of making reference to some of the things I've already talked about. So we picked an example year for Boston, in this case, 2070, and I've picked that middle intermediate storyline, and I've asked, what are the causes of that? And the different colors are showing the different processes. So the big orange bar you see of 1 foot of rise by 2070, this relates to ocean warming and expansion and changes in ocean currents. Again, things that I mentioned earlier. The different blue colors are the melting of different land ice bodies, things like the Greenland and Antarctic ice sheets, and also glaciers. The green is vertical land motion. So this is that reshaping of Earth's surface I talked about. And the final one, which I didn't really touch on, but which also plays a sort of a modest role, it's changes in land water storage. So that is sort of drought and flood on land over large scales. So we're able to, again, this is one example for Boston. We can do this worldwide. And again, we've done this by creating models, which is nothing more than putting into computer code the mathematical knowledge we have about the processes that cause sea level rise.
All right, I want to shift gears a little bit now and talk about some of the impacts of sea level rise. So some of them are pretty clear already: more coastal flooding, bigger storm surges, more potential for damage to coastal ecosystems and infrastructure. Shannon, what are some of the consequences of these changes?
Yeah, so we are definitely already seeing impacts of sea level rise locally here on Cape Cod. We have some roads that are regularly underwater when we have astronomical high tides. We don't recommend that you drive through that. Everyone knows that salt can damage your vehicle. So we have people who have to reroute around their regular routes, plan their days around high tide. We also have...
Before you go on, it looks sunny there. So
yeah, exactly right. So these are conditions when during an astronomical high tide, when we don't even have a storm or high winds. It's a little windy in this picture, but just a regular day when there's no storm can bring flooding to roads in certain areas on the Cape already. So we're seeing that on some of our low-lying roads. We have areas, again, sunny day where water is lapping into people's yards. We have areas where beach stairs go right down into the water. Another beautiful sunny day. Those are supposed to be beach access stairs, but of course there is no beach there during this astronomical high tide. We also have impacts in some of our economic centers that are areas where we have lots of people. So places like Woods Hole, Hyannis, Provincetown. Here on the Cape, we have a lot of tourism, and that drives a lot of our economy. But when we have our economic centers that are impacted by regular flooding like this, it's hard for people to get around. It's hard for people to go shopping, hard for them to get to dining, even hard to access the ferries sometimes. So then in addition to those just regular sunny day flooding issues, we're really concerned about the potential for really increased damage when we have big storms.
And our local audience would have recognized that little video clip was a statue of Rachel Carson that we have here in Woods Hole. Yeah, so Hannah, what about in Boston? What are some of the impacts you're seeing there already?
Yeah, thanks. Great question. A lot of what Shannon says resonates here for Boston as well. So as a coastal city, Boston has a lot of unique benefits to residents and visitors, but on days with extreme weather, we're really reminded the challenges of being that coastal city and that positionality, especially in the face of climate change. So we do experience things like road flooding. So this is a road in East Boston, sort of the aftermath of a storm event where the water is coming all the way up to the road. And that, of course, impacts transportation. It has impacts on cars, economic damages, people can't get around. There's actually a ferry at the end of this road that obviously you're not able to access under these conditions. And then also, damages to people's homes. Here's similar location here in East Boston. An apartment building actually has a deployable flood barrier here into their parking garage, right, to prevent the water from getting in there. So that also prevents you from, being able to access this building. So there are just general disruptions that come from these events. So they not only have economic costs, from physical damages and business interruptions, but also just greatly impact, well-being and sense of safety and ability for residents to stay in the city and really thrive. So when we're thinking about coastal flooding across the city, projections that we use are indicating that we're likely to see about 40 inches of sea level rise, so about 3 feet of sea level rise by 2070. And we really are also thinking about big coastal storm events and where we might see storm surge, right, coupled, of course, with that sea level rise to create risk. So this might look familiar to an image from earlier in the evening. So these are locations in the dark blue. You can sort of see that dark kind of hatched color. That's a current present day extent of a 1% annual chance storm. So that's a frequency storm event that we use for planning purposes to understand where risks might be. And then that lighter blue color is the projected inundation from a similar frequency storm event, but under these 2070 conditions. So you can see there's obviously a lot of extent of flooding. A lot of these places are, coming in and flooding inland areas. So sort of flood entry pathways that not only stick to just the fringe of the coast, but really, move inland as well. And we use data from the state of Massachusetts called the Massachusetts Coast Flood Risk Model to really understand and plan for some of these hazards.
Okay. Yeah, and this map looks a lot like that map that we saw earlier of the historical areas that had been filled in. Exactly. Yep. So the ocean wants its land back, I guess.
Exactly. What it once was.
All right, Ken, let's take some more audience questions.
Okay. Jim was fascinated, he said, by the sea level rise curves out to 2100 and was wondering if there is a corresponding estimate of how many people might be displaced under each potential curve.
That's a really good question. So that's not that's not my area of expertise, but what I can speak to is certainly that there have been estimates. So you have to bring a few things together. With those sea level curves alone, you can't answer the question. You have to bring in either population data or also elevation data. So there have been estimates of, if you have that amount of sea level rise, how much of the coast would you imagine would be inundated, assuming that coastal flooding happens kind of like a bathtub. And so certainly people have run those calculations of, if we're on this scenario, how much coastal population is flooded. I'm unaware, probably because it's not my area of expertise as a physical scientist. I feel like this is kind of getting a bit into the social sciences of, what people do in that case, how many people are displaced. So can't answer that, but certainly there's calculations that have been run about, the populations that would be inundated by this rise.
I can jump in with some data that we've just run on the Cape. I don't have actual population numbers, but about 19% of our land area on Cape Cod is floodplain. So the 1% annual chance storm flood that Hannah mentioned. And under the 2070 scenario, using the same data that Hannah mentioned with the Massachusetts Coastal Flood Risk Model, it jumps up to about 24% of the land that is in that 1% annual chance floodplain.
Yeah, and of course, when we talk about some overseas island nations and places like that, there are places that are going to be entirely underwater. So there's definitely a lot of risk.
You want another?
Sure, go ahead.
Can't find the actual question now, but we had a question about effects on freshwater supplies from sea level rise. Presumably it's salt intrusion.
Right.
What sorts of effects are we seeing in that regard?
Chris, you might be able to speak to that first from a science
I'll try
perspective,
again.
and then
I'm not a geohydrologist, but I can speak a little bit to it. But yeah, I mean, the person who asked the question is really honing in on it. So you have, as the sea level rises, you're going to get that salt water intruding into inland. Okay, so you have this phenomenon called groundwater intrusion. Related to this, you can actually have groundwater flooding. This coastal flooding process that can happen isn't just sort of a wave overtopping a dune, that kind of thing. Because of this saltwater intrusion, you can actually have sort of groundwater effects of flooding further inland in places that you might not expect it.
So groundwater coming up to the surface, is that what you're talking about?
Yeah. So you see this in places like the Outer Banks of North Carolina, for example.
It's something that we are certainly aware of in the policy and planning side of things. We've had some conversations with some other WHOI scientists who are starting to look into that as well. We're concerned about potential impact on drinking water. And also here on the Cape, we have loads of septics. So also looking at how saltwater intrusion could also potentially impact septics. And we have a really wonderful network of Woods Hole Oceanographic Institution scientists and the Sea Grant community so that we can tap into that. but it's research that's currently underway.
I think just to add, I think this is a really great question because it kind of gets at the fact that a lot of these things are really connected, right? So in Boston too, we think about how sea level rise interacts with the stormwater system as well. So, you know, if you get a big storm event and it also rains, how can you drain that stormwater if it's sort of relying on gravity and the sea levels are up really high, right? So drainage just can't occur. So a lot of these challenges are all really interconnected, and it's so hard to just separate out one. I think the septic system is a good example too.
Yeah, interesting. Okay, so we've established that sea levels are rising. They're going to rise more in the future, and the consequences can be damaging and dangerous and costly. What are we doing to prepare and to adapt? Hannah, what is Boston doing? Let's start there.
Yeah, so I know we spent a lot of time talking about everything that's sort of scary about it, and here's where we kind of get to talk about all the stuff that we've been doing and working on, right? So the city of Boston has an initiative called Climate Ready Boston, which is the city's plan and activities to prepare for the impacts of climate change. And so really since 2016 and even earlier, we've been working on figuring out what all of our vulnerabilities are and making a plan for what we can do about it. And so there are a lot of different strategies that the city has identified that can work in different areas of the city. Obviously, it's a heavily urbanized area, so different strategies work in different ways. I think this is a really good example. This is really close to where we were showing photos earlier around Long Wharf and the Chart House. This is the Aquarium MBTA station on the Blue Line, and this is
right. So Boston's subway is called the T for folks that don't know, but yeah. Yes. So we're seeing a subway station here.
Yeah. So it's an underground subway station, an entrance to it, and you can see the sort of plank deployable flood barrier system that the transportation agency puts up in advance of coastal storm events. You know, using projections, using forecasts of what we might expect to see in terms of floodwaters coming up to really stop water from pouring into the system. This was basically, this investment happened after that 2018 storm that Shannon was mentioning earlier. That was really a storm of record for the region and for Boston as well. So that's an example that the city really tries to focus on what we call district scale flood protection, which is providing protection for large areas of neighborhoods. And so we do that through a variety of means. There are some good examples of some city-owned park spaces that have incorporated flood protection into the design of the park. So here you can see the seating on the left of the photo. This is Langone Park and Popolo Playground in downtown Boston and North End. And that seating actually acts as a flood barrier. So when we're doing projects, we're trying to think about how will this sort of perform, of course, during a flooding event to provide protection, but also what else can it do? It's not only a single-use project, right? How can this perform when there isn't a flood event? What can we get out of it? What benefits can people enjoy from it? So it's sort of easy to visualize in these park spaces where you can see people interacting, and recreation is a big part of that. Here's another example, Martin's Park in the Seaport. So the flood protection is built into the play structure. So you might not even realize that there's flood protection there, which is really what we're aiming for, to kind of make it inherently part of the landscape. So providing protection when needed, and then providing other benefits when the flooding is not occurring.
Yeah, that's great. So we're a little more rural here on Cape Cod. What adaptation strategies are we using? And just to let our audience know, we're going to be putting some links in the chat as we talk through some of these adaptations and various resources. So keep an eye out for that. Shannon, tell us about Cape Cod.
Sure. So we've got some really great adaptation work going on here at the regional scale and down to the community scale. We'll talk about individuals later. So Resilient Woods Whole is an example of a really great community scale adaptation approach. So Resilient Woods Whole is an effort that is in partners are Woods Oceanographic Institution as well as others within the village of Woods Hole. There is an advisory board from throughout the Cape and the state, and it is extremely public focused. So there's been so much effort put into getting input from the public and from people who live and work in Woods Hole. So it's a really great effort that has been recognized nationwide as a great example of a way to do a really community-driven adaptation approach. So that's wonderful to see. My office is hosting something called the Cape Cod Coastal Resilience Week from June 8th through the 15th this year. Something new that we're trying. It's a way to get the word out about coastal resilience and about sea level rise and all of the things that we're talking about tonight, things that we can do about it. And the intention is to reach new audiences. We're working with all kinds of new partners, trying to reach people who might not have chosen to tune in tonight or might not be aware of the issues that we're seeing. Some other things that we're seeing, we work with the Cape Cod Commission a lot, our regional planning agency. They've done a great study of low-lying roads, looking at the most vulnerable roads in the area. We've also looked at potential model bylaws to address regulation of new development in flood-prone areas. We also have some flood design guidelines for areas that are prone to flooding, but we want them to still look aesthetically pleasing here on the Cape. We do have a community character that we are proud of and that we like to keep. So you're seeing some pages from these flood area design guidelines that are intended for architects, engineers, contractors, anybody interested in adaptation at both the neighborhood scale and the building scale. So there are all kinds of different options in here depending on the specific situation and even some special considerations for historic structures. We're also seeing a lot of home elevations. Home elevations are probably the most common thing that we see at the individual level for adaptation, and we can talk more about individual later. But some people are elevating voluntarily because they have been flooded too many times, and some are being elevated because they have to comply with the building code. But we see home elevations all over Cape Cod, and it's the best way to, if you're going to stay in the same place, the best way to protect yourself from flooding is, of course, to remove yourself from that flood-prone area. But if you need to stay in that area, then the best way to protect yourself is to elevate that structure.
And so obviously if your home is flooding, you have a direct driver for why you would want to adopt some of these approaches. But what are some of the other things that are driving people to move towards coastal resilience?
Sure. So there are, so coastal resilience and adaptation to sea level rise has been something that we've been aware of for a long time, but it's been kind of this nebulous future concept. And now we're actually starting to see the impact. So some of these adaptations are really starting to be driven by experiences. So things like this, people having to drive through flooded roads on their way to work or to go to the grocery
Don't do
store.
this.
Don't do this. Yes, do not drive through flooded roads. One, your car is not going to survive it. Two,
I should say, Hannah, Shannon, that car is not driving there. We'll make that very clear.
Right. Yes. Right.
Well,
Thanks,
good.
Chris. Right. That car is stuck there. It's not going.
Sometimes it can be really hard to tell how deep water is. So I know there is a temptation sometimes to try to keep going and, don't.
Exactly. Yeah. 6 inches of moving water can knock a person off of their feet. A foot of moving water can wipe away a car. So it really is dangerous to drive intentionally through floodwaters. So more floodwaters on our transportation routes are one thing driving adaptation. Another thing is when roads get washed out regularly, or covered in debris like this, the towns have to make decisions about how much money they're going to put into constant repairs. The same stretch of road can be washed out or undermined 3-4 times a winter, and it can cost $30,000 to $40,000 to repair it and put it back. So then towns have to start looking at, okay, what do we have to do to keep this from happening? We're spending too much money on this. We don't have the budget for it. Some other things that are driving people to adapt. Homeowners are looking, we talked about elevation. Elevation's expensive. So homeowners are also looking for other ways they might be able to protect their homes. Hannah mentioned those deployable flood barriers like around the subway station. You can get those for your house too. There are also people are experiencing serious mental and emotional distress from repeated flooding. People that have had flood damage in their homes 2-3 times in a short period of time, they either want to adapt, so elevate their house, or some people are even thinking about moving and relocating outside of flood-prone areas. And then one other driver is also real estate values. We're not seeing it too much yet. Of course, coastal real estate is prime. Everyone wants to live on the coast and see beautiful views of the ocean. But people are starting to understand that it comes with more risk of flooding. And we had one example very recently on Nantucket Island. A house was for sale for 1.5 million, and then in a very short period of time, erosion took a really significant amount of beach from in front of that property, and the price dropped to $600,000 after that. That's a really extreme example of not seeing quite that level on a regular basis, but we are starting to hear a little bit about potential impacts on real estate from the impacts of regular flooding.
So as I mentioned earlier, we're talking a lot about Massachusetts tonight, but some of the people, as we said, most at risk from sea level rise and its impacts live in parts of the U.S. or parts of the world that may not have the same resources for some of these strategies as we do here. Can any of the approaches we've been talking about work in other places? And in particular, are there some maybe lower cost strategies that don't involve major changes to infrastructure? Hannah, what are your thoughts there?
Yeah, it's a great question. We've been talking a lot about, urban areas and big infrastructure projects, but one other thing I wanted to touch on is a sort of category of solutions that are called nature-based solutions. And so these really involve like intentional use of nature and natural features like beaches and dunes, marshes and mangroves that either alone or combined with some larger kind of what we call gray infrastructure, so big sort of typical infrastructure projects can reduce risks that are from coastal hazards and deliver multiple environmental and socioeconomic benefits. So that previous photo there, that's Belle Isle Marsh, which is in East Boston. So again, sort of close to Logan Airport. This is the type of feature that we see in the Boston area, again, sort of heavily urbanized, but there are some of these really precious natural resources that do provide protection from things like wave action, and like I said, can be coupled with some harder infrastructure to provide more comprehensive protection as we're seeing these real changes. And then the next photo, what this looks like in some other places, I think mangroves are a really great example of this that are found in a lot of places all over the world and can provide really, really substantial protection from wave action, and in addition to a whole range of other ecosystem and environmental benefits that are really, really important. So we think about co-benefits, we think about multiple things that come from these projects. It can be things like recreation and enjoyment, and also really good for ecosystems and species maintenance as well, which are also, of course, other pressing problems. So these types of solutions are about maintaining and encouraging these types of resources, ecological resources to continue to thrive and also provide protection as well. So these can really provide a lot of protection in different contexts.
Right. So protecting these kinds of areas, and also in some cases, I think people are restoring areas that used to have maybe a salt marsh and but for whatever reason was drained, and now we're trying to bring those back. Hannah, as a follow-up to that, is Boston sharing any expertise or lessons learned with communities in other places?
Yeah, it's a great question. We're always trying to learn from each other and share and grow as much as we possibly can. I think a good example is a coworker of mine previously went on a trip to the Netherlands to learn about their approach. I think many people know the Netherlands as really a key player in resilience. This is an image of a very, very large scale storm surge barrier in the Netherlands. And so in advance of a storm event, these sort of two white arcs would come out together and form a block. There you go. You can see the block of storm surge coming up this channel to really protect, you know, a large urban area. I think just going back a few slides, I think, you know, in Boston, we kind of think about maybe not relying only on one piece of infrastructure, but sort of doing what we call a layered approach. So I don't expect you to read all of this, but from this image, you can kind of see a range of strategies that provide different types of protection across the city, right? So in the green are kind of infrastructural approaches like temporary flood barriers that we were talking about, or protective or floodable parks. And then that's combined with things like zoning, which are sort of shown in the yellow. So programmatic changes that are policy level and can cause changes across the city and provide levels of protection. And then sort of in the blue, you can see building scale changes like elevating mechanical systems or putting in some very local green infrastructure to help with kind of immediate flooding right around buildings. So all of these strategies together provide sort of a safety net, a layer of resilience protection, where if one strategy maybe didn't meet all of the need, some floodwater got through, there would be some redundancy in the system that would provide additional protection. And there are plenty of places in the US that we learn from that use very different approaches. And I think there's really no one size fits all strategy. And a lot of it is really dependent on the local context and what residents sort of express as their most important. I think, you know, Shannon talked about that a lot earlier, the kind of community engagement process, and is really important and can really shape the approach that different places take.
Yeah, so I want to go back to you, Shannon. You touched on this earlier, sort of hinted that there might be some things that we as individuals can be doing to prepare for sea level rise, to protect our homes and family. So short of elevating a house, what else is, what are some other strategies?
Yeah, so there are all kinds of things that you can do. And all of these things that I'm going to talk about can be found in the Homeowner's Handbook to Prepare for Coastal Hazards. I think we also have a link to put in the chat for folks.
Yep.
So this is specific to Massachusetts, but if you are in the United States, in a coastal state, you also have a Sea Grant program, and you may have one of these specific to your state as well. But a lot of the information that is available here is relevant to everywhere. So if you miss something that I say, feel free to look this up. The first thing that I would say is go to the link that was just put in the chat, which is the MAP Service Center from FEMA. The first thing you want to do is find out your flood risk. Find out, are you in a floodplain or are you near a floodplain? We see that about 25% of flood insurance claims come from outside the designated floodplain. So even if you're not in one, if you're near one, you might want to think about what that means for you. If you're having trouble with that, or if you want some more data, you could reach out to your town. If you're on Cape Cod, you can reach out to my office. That's something that we provide, is helping folks understand that flood risk. Other things that you can do if you own a home. So of course we talked about you can elevate. You could also fill in a basement if you have a basement. And then if you do that, you should install what's shown here, which are called flood vents. So this seems counterintuitive. A flood vent actually allows water to enter the crawl space of a structure. But the reason that we have these is because if there's water pressure sitting outside of a hollow structure, water is heavy. So there's so much pressure on the outside of a foundation that because it's hollow inside and that pressure isn't equalized, it can actually crack the foundation. So what the flood vents allow to happen is to equalize that pressure so that the foundation remains structurally intact. That's the same reason that you'd want to fill in a basement. A basement is not allowed to be built on a new structure in a floodplain. Here we see the flood vents a little more closely. If you look around near the water, you'll start seeing these if you look for them. They're everywhere. So they're a really great tool. Elevating utilities above flood levels. And then also I want to mention, you should always get a building permit before you do anything structurally to your house. Some other things relate to insurance. So maybe you don't own your house, or maybe you just don't have the ability to structurally change your house. But just 1 inch of water can cause really significant amounts of damage. And a lot of people don't realize that flood damage is not covered in most homeowners insurance policies. So here's your moment to think about looking at your insurance policy and find out, does it cover flood insurance? And if not, look into getting a quote for flood insurance. No matter where you live, if it rains where you live, then you could have a flood. So it's worth looking into flood insurance to help you deal with the damage if you do get a flood. And then one more note on flood insurance. So flood insurance is expensive. So something that the federal government here in this country has created and that we've really taken on in Barnstable County is something called the community rating system. And basically that provides discounts on flood insurance for everyone in a town in exchange for that community voluntarily participating in this program and taking on actions that improve flood safety. So in this graphic here, if you are on the Cape, the darker colors mean that your town does participate in this program, and the darker the color, the higher discount you get. So if you are on the Cape and you live in one of these towns, take a look at your flood insurance policy or consider getting a flood insurance policy because it will be a little bit lower because of the efforts of your local government.
All right, we're running a little bit behind schedule, so I apologize to our audience for that, but I do want to ask a couple more questions. One is to Chris. You're a scientist studying sea level rise, and as an ocean scientist, what do you see as your role in the broader societal response to sea level rise and climate change more broadly?
Yeah, thanks for that, Veronique. So I think more generally, you're seeing more academic scientists engaging in the world outside of sort of ivory tower science. So one way that I've tried to do that is through our education program here at WHOI. So training the next generations of scientists, not only to speak the language of math and physics, but also to have a vocabulary to be able to engage with and tell stories to non-scientific audiences. So what you're seeing here, so the past couple of years, I've had the opportunity to support some students in our PhD program in going to the United Nations Climate Change Conference. So last year, this was held in Dubai. So here's me with the students that I traveled with as part of the Woods Hole contingent to the COP. We were participating in what was known as the Ocean Pavilion. And this was fantastic for the students, right? I mean, this is a meeting the whole world is at. There were upwards of 100,000 registered participants. And these kind of experiences for the students are really, really formative in shaping what opportunities they seek out next. So that's one way. Another way is to try to provide coastal communities with the data that they need to respond to rising seas and flooding. So we've been talking a lot about coastal impacts and flooding. Now, right now, to sort of counter, or not counter, to sort of put up against what Hannah and Shannon have been saying, we don't have nearly enough measurements of the coastal flooding process. I mean, we're seeing a lot of images of how you can get differences in flooding, like road to road, house to house, and that current tide gauge network that I mentioned earlier just isn't satisfactory to get that. So what I've been doing is working with other Woods Hole scientists and engineers. What we're showing here is we've tried to develop these really sturdy, robust, what's pictured here, water level sensors. The idea is that these can monitor coastal flooding and water levels, but they're inexpensive enough that they can be sort of put out in coastal towns and cities by the dozens to really map, where it's flooding, when it's flooding, why it's flooding, and that's the kind of information that coastal communities need to respond in these sites. So those are some of the ways that I've tried to sort of engage with solutions.
Yeah, absolutely. That's great. All right, so we are just about out of time, but I want each of you to answer one last question. Climate change, sea level rise, these are big, complicated issues. They can seem pretty daunting. What keeps you doing the work that you do, and what gives you hope at the end of the day? Let's have Shannon, then Hannah, then Chris.
Yeah, so what gives me hope is the fact that we have an opportunity to do all kinds of innovative work and think really creatively about solutions, and that we have a wonderful opportunity to work together as communities to have a shared vision for the future of our community. And we have an opportunity now to make that come to fruition.
All right, Hannah.
Yeah, I really want to piggyback off of what Shannon said. I think what really excites me and gives me hope is that we sort of have these projects, these resilience projects, as an opportunity to make positive change in a way that people in the community have really identified as needing, right? So we're not thinking about, oh, this is only a flood wall or only a coastal protection project, but this improves quality of life in another number of ways, and be it recreation, be it air quality, be it access to the shoreline that people really, really want. So just thinking about the opportunity and a way to continue to make positive change in the city for the residents who call it home.
Great. And Chris, you get the last word.
Yeah, I would just sort of elevate what Shannon and kind of already been saying, and also reiterate some of the things that I said earlier. I mean, there's just to really put a point on it, like there's been a really tectonic shift in how we as scientists do science nowadays. Before, it was like you just really concern yourself with publishing papers in scientific journals, but now you're seeing much more of an engagement outside of academia. And like I was just saying, like the students, we have these students who are really eager to sort of make that change. And so we're training them not only to do rigorous, good, thorough science, but also to integrate that into action. And as a result, you're hearing stories like what Shannon and Hannah are saying. You're seeing real sort of connections between scientists and practitioners, and you're seeing the kind of real strides towards solutions in coastal resilience, like we've been hearing.
Yep, it's very exciting. Unfortunately, we have to leave it there. I want to say a big thank you to Shannon Hulst, Chris Piecuch, and Hannah Wagner for joining us to talk about sea level rise and adaptations. Thank you also to my WHOI colleagues who've been working very hard behind the scenes to make this event possible, and to everyone who joined us on Zoom, Facebook, YouTube, X, and LinkedIn. Thank you very much. Tonight was the third episode of our 6th season of WHOI's Ocean Encounters events. Our next Ocean Encounters is scheduled for May 22nd, and it'll be about life in the ocean. Please watch our website, whoi.edu, for more details about that. In the meantime, you might want to take a look at the very cool merchandise on WHOI's online store, shop.whoi.edu. You get a 15% event discount for joining us tonight. Just type in the discount code RISING. If you enjoyed tonight's Ocean Encounters program, you can be part of WHOI's solution-based approach to ocean science. If you're already a WHOI member, thank you very much. If not, please consider joining. You'll be providing crucial support for our outreach and our science, and you'll get some great benefits in return. Memberships start at just $40 a year. The average gift is $120, but any amount helps. Your support will make a difference. On behalf of Woods Hole Oceanographic Institution, thank you and good night.
Out where the seas are the deepest and the mysteries the greatest lies our future. The ocean is our last unexplored, ungoverned frontier. The life support system for our planet, inextricably linked to our climate and weather, and to the lives and livelihoods of countless people around the globe. But even against the ocean's vastness, humankind can be a formidable force. What happens next demands action that is rooted in scientific understanding and unvarnished truth, because our world stands at a fork in the road. In one direction, we watch the ocean being catastrophically altered beyond its ability to sustain us. In the other, understanding outraces exploitation, and we help steward and protect this most precious shared resource. What will be the legacy of the 21st century? Together, we can unleash the world's most creative minds, passionately dedicated to ocean science, engineering, education, and policy. Together, we can provide the expertise needed to know what works and a trusted voice to present the facts as we uncover them. Together, we can shape the future. We can inform governments, businesses, and conservationists. We can generate new knowledge in service of society. We can be the catalyst for change. It is more than our responsibility. It is the defining moment of our generation. We are explorers, students, and stewards of the ocean, and this is our time.